Hey everyone, how's it going? Dan here, co-founder of PromptUp. Hope you're having a great holiday season. We got a quick and short, but very practical video today, all around kind of automating chain of thought reasoning, essentially, and how you can do this for any model. And so, as we've seen with more recent models from OpenAI and Gemini Flash 2.0's thinking mode, which came out in the past couple of weeks, there's this push to these new kind of like reasoning models that do chain of thought reasoning at inference time. Before we were kind of doing this via prompt engineering. Now it's looking like that's going to be baked into at least certainly some models that already exist, and so maybe going forward into the future. And so for the models that don't have this built in, we do chain of thought is like a good way to increase reasoning performance. And a very popular way that this was done was to create reasoning chains for examples of similar types of tasks. So if you had like a math example, you would create a bunch of derivatives of those typical math questions and create the reasoning chains in some capacity. And then you could use those as few shot examples. And that was like a really good way to show the model how to reason. And so that would be like few shot chain of thought. We cover this in our few shot prompting guide. But a more simpler way would be to try to use these kind of like directives, like let's think step by step. And those had varying effects. And they were really sensitive. It was really like these types of pieces of prompts can be very different for different types of models, which we've covered in the past as well. So it was really hard to know. And like the best way to do it would be to have the few shot reasoning chains built out. And even though we have reasoning models that are doing this automatically now, there's not a lot of transparency. OpenAI in the API isn't giving us the reasoning chains or the reasoning tokens even being generated. We just get charged for it, and then we don't. There's no way to kind of like get in there and debug or see what's actually happening underneath the hood, which makes it really challenging to troubleshoot. And so, today we'll be looking at a framework called AutoReason. It's relatively new. It's not the first of its kind, but essentially looks to automate the process of creating reasoning chains or traces, as they're often referred to, for any given task. And so it's really simple. That's why I like this a lot. As I mentioned, there's other ones that have done this in the past, and we'll cover one in specific. But there was more complicated and required retrievals and other things along those lines. I really like this one because it's really simple and straightforward. It's a two-prompt framework. The first prompt basically takes any given task or query and says, hey, break this down into reasoning steps, and it gives some few shot examples. So there's some examples already built in to the rationale generation. And then the second one is pretty straightforward. You basically take the original query and the reasoning traces, and then that should hopefully give you an output because you've kind of outlined some of the key steps for the model to kind of walk through to kind of reason. And a benefit to this is that you can use a stronger model to generate the reasoning traces, and then maybe a smaller, cheaper, faster model for the final answer generation. And many people think this is what OpenAI is doing with its O1 models to conserve on cost and latency. And so this kind of gives you essentially like the framework of what O1 is kind of doing, but allows you to plug into it, change the prompts, change the models. And we have the template for this. It comes directly from the paper, which will be linked below. But you can try this out in PromptUp, check out the prompt, audit it, test it out for your use case. And so they tested it across, it was really small, it was only two data sets, Hotpot QA and Strategy QA. So the first one being Hotpot. So Hotpot QA is a very simple data set where the questions can almost be like yes or no type of questions. I can't remember an example off the top of my head, but they're pretty straightforward. And so that's this top version here. And what you can see is using, it helps with like on the smaller models. So for older and smaller model. So for a dumber model, 3.5 turbo, chain of thought actually decreased the performance, but auto reason increased it. And then for turbo, we see actually chain of thought and auto reason decreased performance compared to the base. And this is really important to note because as models continue to get better, the prompt engineering that we do with them changes based on how smart the model is. And so sometimes just clean, crisp instructions is really all that you need, and you can kind of overdo it by trying to kind of auto fit these reasoning things that you may be seeing online or anything. Like it's very specific to what your task is. Because this is a simple task, making GPT-4 do all these crazy reasoning to figure out like if these two historical figures knew each other, is overdoing it. On the other hand, strategy QA is a much more intense data set. Requires a lot more thinking. A classic one from this is, did Aristotle use a laptop? And that kind of requires a lot of implicit reasoning and multiple steps of reasoning. And in this case, you can see for both models, AutoReason, increases performance pretty substantially as well. And so takeaway here is that for very challenging tasks, using frameworks like this can be really helpful. And for kind of more easier, straightforward tasks, it might be overkill. And so there we go. Moving forward. So the only other framework we'll cover here is something called Auto's chain of thought, because it's probably the most similar and maybe the most popular version compared to AutoReason. And it's just a little bit more complicated. So it focuses on essentially creating these clusters of similar types of questions and then pulling those in at inference time based on some semantic similarity of the question that you're handling. So you get a question, and then it will pull from the clusters and pull in ones that are similar, and then it has reason chains using it. Let's think step by step for all of those. So it requires data set creation, clustering, sampling, retrieval, all this stuff. And it does get diverse examples, which is really important for few-shot prompting, but it's a lot of setup. Here's the kind of flow, and it'll be linked below as well via our overview. And for those reasons, I really like AutoReason because it's easy to implement, it's adaptable, transparent, and there's a lot you can do with it. And so I hope that helps.